Hello again. This is Math 1120 coming to you from the College of DuPage, and the title of this lecture is Conditional Probabilities and the General Multiplication Rule. As always, I encourage you to be an active learner while watching this video. Our objectives in this video is to learn to compute conditional probabilities and compute probabilities using the general multiplication rule. By way of introduction, according to data from the CDC, about a third of adult men in the USA are obese, and so the probability is 0.333 that a randomly selected US adult male is obese. However, 28% of adult men aged 20 through 39 are obese compared to 40% of men aged 40 through 59. The probability is 0.28 that an adult male is obese given that he is 20 through 39. So the probability is 0.40 if he is older. So these two numbers don't match. So you see it depends how old they are, the probability that they're obese. That means that obesity and age for males are not independent. That means they're dependent. And this idea is called conditional probability. So here's the definition, or at least the notation for it. So the notation, we write P of F given E. So it's P parentheses F, the slash is the given mark, and that is E is red. The probability of event F given event E. And this is the probability that the event F occurs given that the event E has occurred. So for example, in the example that we just talked about, we would have the probability of obese given you're in this age range is 0.28, and the probability you're obese in this age range is this. Let's look at an example. Suppose that a single die is rolled. What is the probability that the die comes up? 3. And now suppose you roll the die again, but this time we are told the outcome is an odd number. What's the probability that the die comes up? 3. Well, in the first case, this was the sample space, so the probability you get 3 is 1 out of 6. But in the second, we knew it was odd, so this is the sample space. That means that the probability this time is 1 out of 3. Notice that the conditional probability reduces the size of the sample space under consideration. So here's a table representing the marital status of males and females 15 years and older in the U.S. These totals are in millions. To find the probability that a randomly selected individual 15 years or older is widowed, divide the number of widowed individuals by the total number of individuals who are 15 years old or older. And you get those numbers from the table. You can just point and click, and you get this as your answer. Now suppose we know the individual is female. Does this change the probability she is widowed? Well, we'll find out. So what you do is you click at the number of widowed females divided by the total number of females, and you get this answer. And you see those two things are different, and so that means that does increase the likelihood that someone is widowed if they are female. And that leads to the following definition or rule. So if E and F are any two events, then the probability of F given E is the probability of E and F divided by the probability of E. And if we're just counting from a table, that is the number in E and F divided by the number in E. And I'll say it again. The probability of event F occurring given the occurrence of event E is found by dividing the probability of E and F by the probability of E, or by dividing the number of outcomes in E and F by the number of outcomes in event E. So we're using the same table. We're to compute the probability that a randomly selected individual has never married given that they're male. And we're also to compute the probability that a randomly selected individual is male given that they never married. Well, here, the probability that they never married, given that they're male, We're going to assume that they're male, and that means that we have 122.5 in the denominator. And then they never married, and male was 41.6. That's the ratio, and we get this as our answer. For the second one, we're supposed to find out the probability of male given that you're never married. Well, if you're never married, this is how many people you have, and so it's going to be the ratio of this number to that number, and we get this as the answer. Here's a problem for you to give a go. In a Harris poll, we're saying, when you see an ad talking about made in America, are you more likely to buy it, less likely, or it really doesn't affect you at all? And this is the data from the survey. So here are the questions, and really what we're trying to figure out is, does that depend on your age? Okay. So anyway, here are the questions we're going to do. What's the probability of, if you're in this age bracket, that you would be more likely to buy this? What's the probability if you're in oh, this is a conditional probability. Given that you're there, what's this probability? And are 18 to 34-year-olds more likely to buy a product emphasized as made in America than individuals in general? You know what to do. Let's see how you did. Okay, so the probability that you're more given that you're more likely, the probability that you're in this age group is the and divided by the number more likely. These are the two numbers that you get, and this is the answer to part A. In part B, the question was, given that you're in age 35 through 44, what's the probability you're more likely? These are the entries you get from the table. You do the ratio, and you get this as your answer. And if it is a different age group, we compute it, and you get this. And for individuals in general, these are the row totals and column totals, and grand total, you get this. And so the question is, 18 to 34-year-olds are less likely, because that was 43% and change, almost 44%, than individuals in general, which was almost 62%. We don't always have tables, though. Sometimes we're just given numbers. So suppose that 12.7% of all births are preterm, and this defines what preterm is. The gestation period is less than 37 weeks, and 0.22% of all births resulting in a preterm baby who weighed this or more. So that's not very often does that happen, because that's a pretty heavy baby. What is the probability that the randomly selected baby weighs more than that amount, given that the baby is preterm? And is this unusual? Okay, well, we're going to use the definition then. So what we're going to do, the probability it weighs that much or more, given that it's preterm, is the probability it is that and preterm, divided by the probability is preterm. You punch in those numbers, and you get this answer. Now, this is less than 5%, so we declare this as an unusual outcome. Here's a problem for you to try, and this is in Chicago because Michael Sullivan, who wrote our book, is near Chicago. He is in Joliet. So anyway, he talks about the 37% of the days are cloudy in June, and 21% of the days are cloudy and raining. What's the probability that a randomly selected day in June will be rainy if it is cloudy? Again, he's asking about conditional probability. You know what to do. And we will see how you do when we start the next video.